Okay, moving on from where we were, we've talked about exponential functions and we've talked about the special exponential function e to the x. What I want to do now is take a little bit closer look at it and think about it in terms of calculus. And I'm going to tell you something that's going to rock your world, that the derivative of e to the x is e to the x. What that means is, if you take a look at the function, so for any value of x on this function, that'll have a particular range value, that the slope of the tangent at that value, so if I come in like that for a slope of the tangent here, the slope of the tangent when x equals this value is going to be e to the x, this range value. So once again, I'm going to just draw it out one more time so that you actually see what I'm saying. What happens is, if I have the curve e to the x, okay, there's f of x equals e to the x. Those are my e's, I'm sorry, but you'll have to learn to live with it. And if I come up with the slope of the tangent anywhere to that curve, so the slope of the tangent to this point here, x, and this point here would be e to the x, so this point would be x e to the x. The derivative of this tangent at that point is also equal to e to the x. And that is freaky deaky. Now, you shouldn't take my word for it. I should have to prove everything to you. So let's take a look. And I've written most of this out for you, so all you have to do is follow along. Okay, gonna zoom in a little bit. Starting off with proof f of x equals e to the x. That's what I want. What I want to show is that the derivative will be e to the x. So this is by definition. Okay, that's the limit as h approaches 0 of f of x plus h minus f of x over h. Now for this particular curve, you know that what we're looking at is e to the x. So f of x equals e to the x, and f of x plus h equals e to the x plus h. That's how we get this. Now I want you to notice this, that if I have e to the x plus h, that using exponent laws, that's the same as e to the x times e to the h. If the bases are the same, then we add the exponents and keep the same base. So what that means is that this e to the x plus h minus e to the x that I have here could be written as e to the x, e to the h minus e to the x. And using common factoring, taking out an e to the x in both of them, it's going to leave me with e to the x bracket e to the h minus 1. And that's what's happened in between these two steps. Okay. Now I've got e to the x inside a limit as h approaches 0. E to the x doesn't care what happens as h approaches 0, so I take it outside the limit, and it leaves me with e to the x, limit h approaches 0 of e to the h minus 1 over h, since e to the x is not affected by the limit. So I'm pretty close. I've almost got what I want. I'm supposed to be proving that the derivative of this equals e to the x. Here's my e to the x. So the question now remains, what is that equal to? So we're going to take a look, and the only way I have of doing this at this point with our mathematics is charts. So we'll take a look at what this limit is as h approaches 0 from the left and as h approaches 0 from the right. So I've written this out for you. I've done the math for you. You can plug those in. You probably should try. If ever I ask this for you on a test, you can always say to me, we know that the limit as h approaches e to the h minus 1 over h equals 1, but here's your proof. This one's approaching 1 from the left, from the right. This one's approaching 1 from the left. They are approaching the same value, therefore the limit exists and it equals 1. What that means is, where we left off back here, remember, we had e to the x and we wanted to find out what this limit equaled. Well, what we know is, if we come back here, we've now determined that this equals 1. So this is going to be 1 here, and that's going to equal e to the x. And we have just proven that if f of x equals e to the x, then f prime of x equals e to the x. I've proven it to you. Using the chain rule, and this isn't quite as understandable just yet given our mathematics, so you're going to have to trust me on this one, that if I have e to the g of x, the derivative will be e to the g of x, the same thing, times g prime of x. And unfortunately, I can't prove that to you just the way I want to right now, but we're going to have to take that at face value, and I'll do some examples. We'll come back with those examples.